Hello, welcome to episode 14. So you might be wondering that if tuples are immutable, are we just stuck with them? Are we able to ever modify them? Is there a way to work around it? To answer all of those questions, yes, you can work around it. So if we have a tuple here, we'll just create a tuple. Our typical elements here. And fat finger it. There we go. So one of the things we can do is we can make it into a list, and we can pass in the tuple to make our list. So we're taking the tuple that is assigned to X, and then we're using that list constructor like we talked about before, and we're just passing in this tuple. And then now we can say Y element whatever we want. We'll just do 1 equals we'll just call it inserted so that we can see it very clearly where it is, and then we can make X now equal tuple Y, and then we can print X. So if we open up our terminal here and we run pi 14.py, we see that it inserted it. Now notice it didn't push this element at all, it just overrode it. So it just changed the value, right? It didn't insert and move 2 to be element 2 and 3 to be element 3 or index 3. It just overrode the string of 2 with the string inserted. Since they're immutable and they don't have a built-in append method for tuples, there are some other things that we can do with those as well. So again, we'll just take this tuple, Control C, and it's a tuple because it's in parentheses or round brackets, as we like to say. And then we can again make another list. X here, and then we can just take Y and we can append it whatever we want to append. So in this case, I think we'll do 4. Go ahead, append that, and then we can say that X is equal to tuple Y. So very much the same pattern, and it's good to pick up these patterns if you need them. I think that patterns are probably more important than remembering all of these methods and everything. And you see that we got the tuple, we appended it, and this time it didn't just override any values, it actually added a new element because we're creating a new tuple by using the tuple and passing in Y here after we appended it to a list. Now the other thing you can do, we'll just print our tuple again so that we have it. You can create a new tuple with the value, any value that you want, and you can add it to that tuple. So you could also say we have it here and then we have Y, and remember, if we're going to have just one thing, let's say 4, because we're clever, we want that comma. So remember that we need that comma. And then here we will take X and we'll actually use the plus equal operator, Y, and I don't think I touched on the plus equal, so or I might have touched on it, but anyway, plus equal means like to add this in with the X also. So you're not just adding them together to get one result. So if these were like numbers, it will just append it basically, essentially. So I'll just show you what our output looks like. And it's our addition assignment operator, is what it's called. So you see here, it pushed it on here. So normally if you were to do it with numbers, it would just add 2 values together and assign that final value to a variable. So it's one way to increment through like a for loop or something. You can just do, like, if you remember, we did I plus equals 1. So I think we did actually cover that in the looping section. Now you might be thinking, well, how do I remove something from a tuple? So here we have our tuple, and I think you probably already guessed it somewhat. So we will do turn it into a list, and then we will use that list method of remove, and we will pass in 2 because we hate 2, and then we will assign x to tuple of y yet again, and then we will print x here so that we can see what the result is. We'll go ahead and save, and you see that we removed 2 through this little switch trick that we've been using. You could also just delete an entire tuple if you wanted for whatever reason. So you could just delete x here. Get rid of that. And this is going to raise an error because it's deleted. So we'll save it, and I'll just show you that we get an error saying x is not defined, and that's because we just destroyed it. Okay, so now we'll cover unpacking tuples. When we create a tuple and we assign values to it, that's just called packing a tuple. So whenever we add all those values in up here, this is packing a tuple. So that's it. But in Python, we're also allowed to extract the values back into variables, which is unpacking. And you'll see this in some other programming languages as well. So something you could do here. So we'll just take this and we'll use 4, 5, and 6. Set those equal to x here. And then we can just print 4, 5, and 6. So we'll print 4, 5, 6. Go ahead, save. And you see that we've unpacked them. And so 4, because it's the first element as we're unpacking, we're setting it equal to x, is returning the value for the first element, or index 0, as this would be index 0 as well. So we're assigning them accordingly, as you can see, 1, 2, 3, 4, 5, 6. So when you're unpacking, the number of variables must match the number of values in the tuple. So if we don't have these 3 variables here to unpack those values to, and if you don't understand what this is doing, just think of it kind of like 4 is equal to 1, right? So it's doing that very quickly. So just like we have x up here, it's doing that, except for instead of 1, it might be like x of 0, right? And then x of 0 is the value of 1. But if that makes sense, and then 5 is being assigned to x of 1 here. And then because we don't have anything, right, if we just delete these and we unpack just like this, and then we save and we run it, let's comment that out just so you can see. Comment that out to prevent that error, and you can see too many values to unpack, expected 2. So we have too many values to unpack because they're not matching the number of values here in the tuple. So another thing you can do is use an asterisk. So you could do something like this, where we do it before 5, and we will unpack all of the remaining values into the variable that is 5. We save, print, and you see that we have 1 printing for 4, and then 5 is actually a list that contains the remaining values. And I just want to kind of cover something else. So we're just going to expand this a little bit so that you can see more in depth how unpacking works. So we'll actually change these from 4 and 5. We'll do like now, if the asterisk here is for something other than the end, and we'll go ahead and change this to 12, and we'll also print off 11 and 10 here. Uncomment that, save. We'll see what happens here. So we'll just open the terminal, we'll launch 14.py, and you see that it actually unpacks all of the variables, or all of the values, into the variable with the asterisk until the values remaining match how many variables are left in this list. So since we only have 1 that comes left, it gives 1, 5, like the 12 here, this variable, the value of 5, as you see right here. So, but then it put all the other 3, the middle 3, into the variable 11 and 1 into 10. So if we add like another variable here, 13, and we have that asterisk, then it will only assign it 2. So Python's pretty awesome. It automatically figures that out. It creates it. And just to show you that it's creating a list here, I'm going to go ahead and do type on 11. Just so you can see, if you're ever curious what kind of data type you're getting, like if you see something like this and you just don't know what it is for some reason, you can come down here, you can put type, and then you see that we have one class of list because we're not printing what's in it, 4 and 5. Right, so just always keep that in mind, but know that it is giving you a list for whatever you put the asterisk with. Hello and welcome to episode 13. So I shot this entire episode and realized that my computer was no longer picking up my microphone. So I've already pre-typed out pretty much everything, but I want to go over it all. So this is the first lesson in Python tuples. What are tuples? Tuples are used to store multiple items in a single variable. It's one of the 4 built-in data types. We've already seen lists. The other 2 are a set and a dictionary. They all have different qualities and usage. I mentioned that previously. And a tuple is a collection which is ordered and unchangeable. Tuples, as you see, are written with round brackets. So make sure you're using the appropriate brackets for a tuple. They are not the square brackets for a list. And you might be wondering, well, what's the benefit of a tuple if we have lists? Right, so I want to go ahead and cover that really quickly. And because I'm dubbing over this video that I already shot, basically this text, so I'm not typing along. If I'm moving too quickly, please pause the video, move it around, leave a comment if you're confused by anything, or message me and I'll clarify it. So there are libraries in coding, and in Python we have one called timeIt. So we're going to import timeIt here for a demonstration. So I made a variable x, and with x I'm using that library timeIt to make a list. So you can see the statement, I'm passing in a list as an argument, statement equals list, and then I'm telling it to make that list this many times. So it's going to see how fast it runs, and it's going to time a tuple. So 2 of the perks to tuples is that they're faster and they take up less memory than lists, and we'll demonstrate that here. So both of them are going to run 10 million times, and we're going to make the exact same elements in the tuple and the list, and then we will print the list and pass it in, and the tuple and pass it in. So let me kind of clear that out. We'll come down here and we'll just run 13.py and we'll see what we get. So you can see like the hesitation when it was even running, and that's due to the list. So you can see that a tuple is about 4.5 times faster than the list. So that's pretty significant, especially when you're getting into doing it something like 10 million times, right? Especially if you were doing that like for several users or anything along those lines. You could see where that would save a bunch of time. Okay, next up, I wanted to talk about single elements in tuples here. And before I get into that, I want to cover what ordered and unchangeable is. As you know, you can add, remove, or delete from a list in Python. We've done that. In Python with the tuple, they're ordered. So when they're ordered, it means that the items have a defined order and it won't change. So being that they're unchangeable, it means that we cannot change, add, or remove items after it's been created, and you are able to have duplicates in a tuple. So we would be able to do a tuple like this, and we'll print these, and I'm going to show you here. So this is kind of how you would expect to do it with a list with one item. You would with the square brackets instead of the curved brackets, or you would expect it to just print 1, but I will show you the output. So notice that it's just printing the string of 1. It's not actually still a tuple. So if you want it to remain a tuple, we'll come up here and we'll add another comma, save, we'll run it again. So now it's a tuple. It does look kind of funny, but if you want it to stay a tuple, that's one way to do it. the next thing I want to point out is that our tuple y here has two strings that both say 2 with the same case sensitivity, so it does allow duplicates inside of tuples. So just a real quick note, sometimes you'll hear people call these round brackets instead of parentheses. Sometimes you'll hear people call them parentheses instead of round brackets. Just know that's what they're referring to. It's the same thing. So again, like lists, tuples are able to store multiple data types like strings, ints, and booleans. And you're also able to use that same method that we use on lists, which is type, to see what it is. So when we run this, you see it's a class tuple. And if we want to just print X, just to show that the data types work, we will do that as well. And you see that we're getting those values. Remember not to put your booleans in quotes, which is a common mistake that I make, or it just becomes a string. And right here, I just want to say that the type for tuple, how it says class tuple, from Python's perspective, it's just an object with the data type of tuple. Another way that you can make a tuple is by using the tuple constructor. If you remember, we did this with lists as well. And the important thing is that we're taking a variable named x, we're assigning it, the tuple constructor, we're constructing a tuple and assigning it to x anyway. Notice the double rounded brackets or parentheses here. So I don't want to do that on both sides. So you need that. So if you're ever using a constructor and it's not working, check to make sure you have the right amount of brackets if your IDE does not warn you. And just to show you that that works, we'll save, print it, and you see we have created a tuple and we're passing the values for the elements into the constructor. Okay, now we'll cover accessing tuples, and you see that we have this tuple x with the values string 1, string of 2, 3, and 4, which are integers, and it's just like a list. So we type print, we say the variable of the tuple, which is x, and we're looking for the element at index 0. I keep dragging and dropping. So if we save that, run it, you see that we get the value for the element at index 0. And remember that we're able to use negatives as well, and that will get us the last element inside the tuple. I don't think I talked about negative indexing very in depth before. So basically it decrements from the other end. Instead of starting at the beginning of the tuple, the list, whatever you're passing in, it starts at the end. So -1 was here, -2, -3, -4, if that makes sense. And just like with lists, you can look for a range. So we'll uncomment this. And you can even start with a negative. If you're doing negatives, make sure the larger number is at the end. So we have -1 back here. We want to start here with -3. So again, -1, -2, -3. So we will be starting here and ending here, and we will not be returning the value of this index. So save, run, and we see 2 and 3. It works with positives as well, of course. If we save, run, we see 1, 2, and 3. Even though this is the value for this one, remember that it does not return the value where you stop. So you can also access by searching for a specific value to see if an item exists. So we can do that with a conditional, like an if statement. So we're looking for if 2 is in X, and if so, it will print yes, 2 is in X. Go ahead, save, run that. We don't get any response because 2 up here is case sensitive. So if I change this to a lowercase 2, save, run it again, we see yes, 2 is in X. And again, you can also do like an else statement or whatever else you want. But that's one way that you can search through there, is to check if the item exists.